This is lesson 2.4 for pre-calculus, and this is about average rate of change. Before we talk about average rate of change, let's talk just about rate of change. Well, rate of change is something that we know of as slope, the change in the y being compared to the change in x. When we say miles per hour, which is a rate of change, it's the change in miles compared to the change in hours, miles per hour. When we have linear functions, something that is going in a straight line is the way we think of it, then the slope is constant. Everywhere on that entire function, the slope is the same. It's always, once you figure out, you say, oh, my slope is 7, any 2 points that you find on the graph, any 2 points where you look at the change in your y and your change in your x, it's going to be the same slope. But when we have nonlinear functions, things that curve, things, like we've had in other lessons where I talk about where a graph that looks like a roller coaster ride, where it's going up and down, up and down, up and down, we can't talk about constant slope. So instead of constant slope, what we can talk about is average slope. When we don't really say average slope, what we say is average rate of change. And that average rate of change is where we just take any 2 points on the curve and then we draw a line between those 2 points. So I have these 2 points, point where I say this A, that right here at x equals A, and here where x equals B. I have 2 points on the curve. Well, I'm going to just do a line through those 2 points. Now, if you recall, in geometry and other courses, that's called a secant line because it enters and exits the curve. So this is called a secant line, and I'm connecting any 2 points on that curve and create a secant line. Since it's a line, I can find the slope of the secant line. Well, the slope of the secant line is also referred to as the average, the rate of change between points A and B. Okay, so the slope is, now look at this, the outputs, f of b minus f of a, because that would be this point, is the output for b is f of b, and the output for a is f of a. So I'm having output minus output. This is like saying y sub 2 minus y sub 1. And we're going to divide that by, well, the inputs, b minus a. These have to match up, f of b and then this being b. This is like saying y sub 2, x sub 2. This is like saying y sub 1, x sub 1. Okay? And that is average rate of change. It's the slope of the secant line. And like I said, it refers back to what we think of in our Algebra 1 days as y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. This is the way I will always start referring to it. It's the change in your y divided by the change in your x. So we want to find the average rate of change of this problem. So write down the problem. F of t equals t cubed minus the absolute value of 3t. Now it's over, and this is called a closed interval because we have an absolute equal to negative 3 and this absolute equal to negative 1. So we're going to have, this is my A and this is my B. So what we do is we find our outputs for B and our output for A and subtract them. And then we have our B minus our A. And we get 16. Pause the video if you need to look over the computations, because this is really important that you understand how I used parentheses to make sure that I didn't mix up anything with the negatives and the absolute value. So please pause the video and make sure you have all that work written down. Here's another problem where instead of an equation, I give you a bunch of data. We have particular times and we have the temperature. Our time is our input and the temperature is our output. And our time, the changes in this are hours. So the change in from 8 to 10 would be 2 hours. The change from 11 to 2, well, I always do this, say 1, 2, is be 3 hours, okay? So what is the average rate of change between 10 and 11 a.m.? Well, 10 to 11, that would be my change in X, 1 hour. And then I go over to the corresponding Y values of 40 and 45. The change in my Y is 5 degrees. So that's what I've got for my change in my X and my change in my Y. And the average rate of change is change in Y divided by change in X, 5 divided by 1, which is just 5. And then you have your units. We did temperature divided by time, so it's degrees per hour. What was the average rate of change between 11 and 2? Well, from 11 to 2, I know that that's a change in 3 hours. And I'm looking at the corresponding outputs from 11 to 2. And I notice that that's 10 degrees. So I'm going to do 10 divided by 3, which is 10/3 degrees per hour. And no, I didn't put that in my calculator, and I did not write that as a decimal. I didn't write it as a mixed number. I left it as an improper fraction, just reduced. And that's how I want your answers to be, is to be exact, not approximate, unless at the end of the problem I say approximate to the nearest degree or the nearest tenth of a degree. And that is the end of our lesson on average rate of change.